Okay, good morning. My name is Zhamak. I'm from ThoughtWorks. I'm a tech principal at ThoughtWorks, and I've been working on distributed system architecture and microservices for the last few years. Also a member of our Global Tech Advisory Board, people responsible for publishing Tech Radar. If you haven't seen ThoughtWorks Technology Radar, I encourage you to have a look. We had a recent publication came out end of November. So before I start the talk, I just want to say thank you to NDC organizers. They supported me to fly in from San Francisco with my 1.5-year-old girl sitting somewhere over there and making it possible for me to be here giving this talk. I think thinking about reflecting back on 2017, at least for me, one of the most exciting kind of topics of systems architecture has been the progression of microservices, infrastructure for microservices, and wider recognition of service mesh. Though this is super exciting, it has disrupted the notion of enterprise-grade centralized API management system. And it's really raised a bunch of questions and ambiguity as where API management system would sit in the architecture. How would service mesh and API gateways interplay and integrate? So I had a bunch of questions a few months ago, and to get some of these answers, I hosted a panel of discussions with some of the creators of a few API gateways and service meshes in our office in San Francisco to pick their brain. So what I want to share with you today is first an overview of service mesh, not so much what it is, there's a lot of documentation out there, but more how we arrived at this topology and why service mesh. Then I want to share with you a little bit about kind of the overlap between these two camps of technology, the traditional API gateways and API managements and service mesh, and how these two kind of interconnect or interrelate. And if I really do a good job at that point in the presentation, you will have the same questions that I had a few months ago. And from there, I will talk about a few pointers and, kind of metrics that you can use to make decisions as where to use API gateways, where to use a service mesh, and what the future might look like. So in the kind of Silicon Valley bubble where I am, one might say if you haven't been living under a rock, you should have heard about service mesh. It's a harsh way of saying it. I like the German way much better. Unless you've had tomatoes on your eyes, you must have heard about service mesh. So just a quick raise of hands. Who in the room is familiar with service mesh? Yeah, definitely I live in a bubble. So a little bit about what service mesh is. Service mesh is a dedicated infrastructure layer to have reliable, secure, and safe inter-service communication in your distributed architecture. And if you're building cloud-native applications, more importantly, if you're building microservices or distributed systems, you definitely want one. Here I quoted William Morgan. He's the co-founder of Buoyant, a startup in the Bay Area, and they had a service mesh. They started building one, Linkerd, about a couple of years ago, and most recently they came out with a more kind of lightweight version, Conduit. The reason I quoted him was because him and his colleagues were working at Twitter between 2010 and 2015, and they had a lot of service downtimes and reliability issues. So they went through an interesting journey to kind of come up with this notion, and they coined the term service mesh. In parallel to them, a lot of different engineering organizations, teams have arrived to the same topology, and I will talk about that. So if we do want to build a reliable, fast, and safe distributed architecture, traditionally, in kind of microservices environment, what have we been doing? What have we been implementing? Those capabilities. And before that, let's think about the capabilities that we need to implement for a safe, reliable, fast network. We would need dynamic service discovery, load balancing. We have an ephemeral kind of infrastructure, services come and go, so we would need to be able to find the services dynamically and route traffic with a load balanced cluster. We would need to build resiliency in the architecture so we can minimize the radius and impact of failure on the overall system and on the network. So we've been building retries, timeouts, circuit breakers, and we've been building these capabilities in the services. We would need some form of traffic management, right? We have, let's say, a canary release of a different version. We want to split the traffic between one version and the other, or we want to do A/B testing and based on the weight of the traffic, direct people to different services. We want to be able to trace those kind of calls across the services. So we need observability with open tracing and distributed tracing with logs, get rich telemetry of the APIs and services that are being called, what is the response time, what's the error rate, throughput, and all the good kind of metrics that help us really debug the system. And last but not least, we need a really strong sense of identity for the services. What service is calling us? On behalf of what end user we're running a workload, and be able to enforce a whole bunch of policies around the access control, who can access call what service, and maybe in a more even complex form, and at what time of the day and under what circumstances. I clicked way too far. Oops, sorry. I got a new clicker, and all right, that's where I'm meant to be. Okay, so. It's great. These are the capabilities that we need to build to have fast, reliable, distributed systems. How have we building this? Anyone been trying to do any of these in your architecture? Yep. So one way might have been that we have had, some back-end delivery infrastructure tooling to implement some of those capabilities. So for instance, if you wanted to get telemetry out of your processes, you might have had Prometheus and Grafana sitting on top of it for visualization to get the observability that you wanted. For the services to be able to emit those metrics, we've been investing in thick libraries, shared libraries across those services. Often they call it service harness or service chassis to be able to implement those cross-cutting concerns. But if you're in a distributed environment with autonomous teams, possibly a polyglot technology set or technology stack, what is the challenge with this approach? What are some of the pain points that we have?
Your libraries run in different languages?
Totally. You have to chase all your teams, make sure they actually use the library, they've upgraded to the right version and the recent version. You need to have different implementation of it in different languages, so enforcing consistency would be challenging. And you really decouple the versioning of this and the release of this cross-cutting concern to each and every service that needs to be independently released. So what would be the next obvious progression of this model? Yes, go out of process. So get the capabilities out, put it in a service proxy, deploy it with your service, and have the traffic inbound and outbound for the service go through the proxy. So make that somebody else's problem and decouple it from your code to this logical extension of your code. So the service proxies were one of the first steps that people went through building kind of the service mesh, and the service proxy is the one that out of the box can give you the tracing of the calls coming in, emitting a bunch of metrics, building circuit breakers, and so on. But for this to function, what is the next challenge that we need to solve? Anyone? How do we get the configuration across to all the proxies? How do we get the logs out back to a diverse set of back-end infrastructure that we might have? So one way of doing that is having a component in our network or a modular component in our network that hopefully exposes some APIs for you to get configuration into it, to dispatch the configuration to the proxies, or proxies poll them for the configuration and emit the logs out. And that's often called, I think in most cases, called control plane, data plane for the data going through the proxies, and control plane for the configuration, distributing certificates and getting talking to the external backends. And this is the journey that folks at Buoyant and Twitter had gone through. But this hasn't been the end of the evolution of this architecture. A little while ago, a perfect magical storm happened. Folks at Lyft built a very efficient service proxy called Envoy for routing both TCP and HTTP traffic. They talked to the folks at Google who've been dealing with distributed API management infrastructure for quite a long time, and they had the concept of service endpoints. And I think they had a few beers with folks from IBM and decided to build an open source and fairly open and extensible service mesh technology called Istio, and it was announced in May. It might be worth to talk about a few features that I'm personally super excited when I look at the architecture of the Istio. One of them is that the control plane, it has a nice extension kind of system that you can extend it to talk to different types of backend and delivery infrastructure. It exposes APIs for getting configuration in. The other feature that's really interesting is that they started doing this first on Kubernetes, and now I've extended it to different schedulers. But by using the concept of pods in Kubernetes, which is basically a unit of deployment, a unit of scheduling, you can bundle the deployment and scheduling of your sidecar, in this case called sidecar now, with your process. And you can kind of inject that into your pipeline and don't worry about the decoupled deployment and scheduling of the two containers. And lastly, if you saw, I kind of replaced that whole idea of the gateway with Kubernetes ingress, which is responsible for getting the outbound traffic into the architecture, and ability to extend that with this kind of idea of the ingress controller to use the same technology, the proxying technology that you've been using within your mesh at the edge. Or in fact, use any technology for injecting sidecars into the mesh. People have been super excited about this and started, experimenting with their own sidecars, with their own control planes. Linkerd folks have their own control plane replacing Istio or working with Istio. Nginx announced Engine Mesh back in September. You can inject Nginx as a sidecar or as the ingress controller. So it has a very nice kind of extensibility and modularity to it. Doesn't this look nice? So it's a great architecture, right? I'm excited. It's the beginning. There's a lot of community support behind it, but not too fast. As the medieval French philosopher would say, we've got a doubt to ask the question, and we've got to ask the question to get to the truth. So the question that I had when I saw Service Mesh was, then where is the place for API gateway and API management solutions that we've been using for the last 5 years or so in this architecture, how they are going to interplay? And to think about why this question was important for me to answer, and it was something that really puzzled me. I want to just share a little story with you. I work with a team at ThoughtWorks we call Digital Platform Strategy Team. We consult our medium-sized to large-sized clients building digital platforms. These are the clients that have really bought into this, platform thinking. They have business KPIs associated with the portion of their business that goes through, APIs. They want to build modern distributed systems architecture and microservices. And very consistently, the very first question, so one of the questions they ask us always, what API management system do I need to get? How do I need to deploy it? What sort of topology? And to be frank, this has been actually a difficult question to answer for these clients because, to be honest, a lot of the vendors have moved the API management systems into a very monolithic and central piece of architecture, single point of friction for configuration, for development. And it's been difficult to recommend one. And now it's become even more difficult with service mesh. So let's step back for a minute and see what API management systems have been giving us, right? API management systems market was estimated $600 million 2016, and it's expected to grow to $3,400 million by 2022. So you can imagine that the vendors would want to pack as many features as possible into the systems. But if you look at the last 5 years, most of the vendors have a set of capabilities like the developer engagement. They give you a set of nice capabilities that developers in a self-serve way can possibly use a portal to discover what APIs you have. They can see the documentation. They can dynamically run the documentation. They can see, look at the documentation, exercise a piece of code and see what sort of request responses they would get. As a developer for the service, you can upload your open API spec, generate the documentation. You can have the community notifications, like if the version of the API changes, you can get notifications and have the commenting system there and be able to test APIs. There's a set of functionality around API lifecycle management. Promote your API, secure it, allocate API keys to it, to your clients to use it, or demote your APIs. If you're making money out of your APIs, if you have, you want to monetize that, there's a whole set of capabilities. Apigee does a good job of that for, tracking the payment plans and making payments, so enforcing quotas on your API. API analytics is another big one. Basically tracking the API, KPIs and generating reports. Capturing, sharing, generating reports for stakeholders, people who care about what is the usage of the API, how am I trending in terms of the adoption of the API. But there is a particular set of capabilities here that fall under the API gateway or proxy component that very much overlap what Mesh does everywhere. And those capabilities were usually implemented by the gateway at the edge for the inbound traffic, or the gateway as a proxy, or sometimes known as micro gateways. So then the question is, how are we going to go about this? Like between Mesh and API gateway, how do we get the best of both worlds? So the question we must be asking is, how do I pick an API management gateway that plays nicely with service mesh? And as any good consultant would tell you, the answer is depends. And one of the things it depends on is your kind of architecture journey, where you are in your architecture towards kind of microservices. When we see range of clients that we have, their architecture often falls under this spectrum from legacy monolithic systems to kind of advanced microservices architecture. And it really doesn't matter. You might be a post-startup or startup, or you might be a multi-year large enterprise. So at the beginning of the journey, in this spectrum, you start with kind of some sort of a legacy system. Systems are usually monolithic. They could be, a Node application, or they could be a COBOL application. But what happens is that the monolithic legacy is still containing most of the logic and most of the data, but to support some sort of a 21st century user experience for your mobile applications, you need to expose APIs out of it. So that's the monolithic legacy. How many people in the room deal with systems that look like this? Half of the room, probably. You might have, kind of progress from that step forward a little bit and have built some facade services. That usually happens because it's so hard and costly to change a legacy for, implementing new features. So you might, adopt the strangler pattern of building some services around the legacy to expose a more, developer-friendly set of APIs. Often we see this architecture in the boundary of the organization, so you have the digital part of the organizations going with services, and you still have the corporate part of the organization dealing with legacy. How many people have systems that somewhat look like this? Okay, you probably have a combination of those two as well. And there are different revisions of this that you can go through, but at the end of the spectrum, you've got, larger number of services built around your business capabilities, and you've got a large number of interconnectivity across your services. And it really doesn't matter that service is sitting at the edge, exposing APIs, to different user experiences, or the service is some sort of a core capability that other services are using. They're equally services and have the same kind of features. So if you look at this spectrum, what sort of characteristics we observe? If you're at the beginning of the journey, there aren't many inter-system connectivities. If you are moving towards microservices with larger number of services, you have the larger number of interconnectivity. What that means is that those concerns like resiliency and the tracing and dynamic service discovery, those are the concerns that you really want to think about and implement in your architecture. Your mental model about security shifts. If you have a monolith with a bunch of APIs, or even sometimes some facade services, you are comfortable with the idea of security at the perimeter. I'm going to put some zoning in place, some gateway in place, and to monitor the traffic coming in to secure that, but the network within, or the application that runs those business logic, I'm happy for it to be considered, anybody within their network, I'm happy to be considered secure. As you move to the microservices, you really, no matter how secure your network is, your mindset shifts to zero trust environment, where you want to authenticate every service-to-service call. You want to authorize who can call who, and you want to authorize and authenticate the end users on behalf of which we're running the services. We have a lot of clients that they do want mutual TLS termination at every service, between every service. They want to have auth between the services. Observability changes, right? When you have just a small set of APIs or number of services, you care about observability at the edge. What calls are coming in? What's the response time to my clients? What are the failure rates? But with the microservices, without observability at every service, we'll be operating in the dark. We can't even debug issues. The next two ones are some curious ones that I really like when this sort of mind shift happens. People who are starting from legacy and building some services and APIs, they have this strong separation between how they treat their users, a user of those APIs if they're external, and the user of APIs if they're internal. So if you have some sort of external API users, you care about your API documentation, how easy people can find APIs, how easy is the experience of writing a hello world from, I want to use an API, I found it, I used it, I can get to the endpoint. But if these are APIs internally, you probably have to go knock on everybody's door to find out if you have an API or not. In a microservices world, you really want an equally delightful experience for all your developers, discovering the APIs, using them and testing them, good documentation, good testing. And finally, this idea of what an API is kind of changes. For some reason, when I talk to people, they think APIs are these magical things that we sprinkle around the edge of our applications, and it's really at the edge of our software. And there's this dichotomy and the duality of the APIs that we expose to the client applications and inter-service communication. To me, every service-to-service communication is an API in a microservices. APIs are the fabric of your integration, whether it's gRPC or RESTs, with JSON or events. It's the surface, how you surface your capability of service. So that's why I sometimes interchangeably use APIs and services kind of to make my argument. So we have seen now the capabilities that API management systems gives us. We have seen this kind of spectrum of the architecture. So what's the answer? I would have loved to come out today and say there is a new great way of doing API management and that service mesh and its extension to it, but I can't just say that. For a lot of us, we're still in the legacy world. We're dealing with one monolithic applications and a bunch of APIs, and what you're looking for is a stopgap to get the traffic between your client and your backend application under control. You probably just want to you probably have a hard time changing that monolith, so you want to have an external components that deals with some of the, gives you some of the observability that you want at the edge, as we talked about, some security of your APIs at the edge. And as you start moving to kind of more proxy services, if you still haven't, so there's a little bit of some conditions to consider here. If you still haven't moved to the containerized world, you probably have some sort of a contract with an existing, API gateway system, but you want to get those observability and the rate limiting and API documentation across the services that you have within the organization. This model would be a small mutation to what you have, which is having the edge gateway for your incoming traffic and kind of a hub of gateways or proxies in this case between the services. Some products that we've used in this configuration and worked really well to name are, for instance, Kong. I don't know if you guys have used the open source API gateway Kong. It's a lightweight gateway built on top of Nginx, so it performs very well. You have to think about the performance of this configuration because you've got another network hub to go through across all of your services, so you really want to test the performance of the gateway that you pick. And it's fairly lightweight. If you're serious about building more services and expanding on this, I would say this has a very short runway for you because you want to kind of get into the mesh world and be cognizant of the commitment that you have to the product you choose, go lightweight, or the cost that you're going to incur to have this. But if you're still already in a world that you have an edge gateway, this can be kind of the progression to that model. Do we have anybody in the room that has this kind of hub proxy for inter-service within your services communication that you've applied the same edge gateway product that you had? Yeah. Try to. Yeah.
Basically, I think we're trying to do right now.
Trying to do right now. Okay, I'm just curious what product you're looking to.
It's HR management system.
Okay. Yeah, this is one person trying. Yeah, it's not a very kind of well-known. It's one of the large retailers in US that I worked with a few years back, actually. They had an edge gateway where very soon they decided, well, we need all these capabilities across our services as well, so why can't we put one of these in the middle? The problem is that most of the gateways actually build both gateway and the management into one product, so you're not going to be in a good position in terms of the performance and the configuration of these. Some have the concept of micro gateways, but it's something to consider if you're already in this space using gateways. I wouldn't jump into this if you are building large number of services. So for any other case, I would say for inter-service communication and all those cross-cutting functions that we mentioned to get visibility, to get seriously consider service mesh. But then one question. Actually, there will be many questions because the next question is, okay, which mesh will I pick? And we'll get to that in a minute as well. But there's still one question stands here, is that we had a whole lot of other bubbles, if you remember, around API documentation and other capabilities that meshes don't really provide and that they're not concerned with, at least right now. So how do we get those ones? Does anybody have an answer? Because I'm looking for the answer as well. All right, so the answer is that right now I would tell you in this very interim place we are, because this space is changing very quickly, is take a toolkit approach. So if you're deciding to use a service mesh, then think about products that open source or commercial, on-prem or SaaS, that gives you some of these capabilities that you want. For instance, Swagger has been around for a while in a SaaS model or an on-prem, and that's a good enough product for getting your documentation out to the users. There are a whole lot of libraries, if you go back to the technology radar I referred to at the beginning, that you can use. We've published some of the other tooling that comes with it for sanity checking the API spec that you have with the documentation and updating that automatically. If you want to use some of the other SaaS projects, readme.io, it's a new startup again in San Francisco. If you look at their websites, they give you a dynamic kind of document generation with that kind of nice 3-panel design that you can connect to any kind of backend services that you have. And I guess a hint here for people who are up for innovation, there is a space for innovation here. We don't have a lot of good solutions, so any open systems that can plug into the service mesh and provide API gateways, it's going to be an interesting one. Maybe the next option, again, an interim option, is pick an API management that supports the mesh. And there are different ways of supporting the mesh. Again, Kong, as I mentioned earlier, they've gone down the route of actually with Nginx being the first API gateway that can run as a sidecar itself. The challenge with this model is that unless you buy into Kong as a sidecar, you're not going to get all the other nice documentation and the other management features. So you have to kind of buy into the proxy as well as kind of the rest. There is another open source software out there. I haven't really looked closely at it, Ambassador, that claims to also be an API gateway, lightweight kind of management solution for this, but I haven't personally looked into it. Again, it's not a well-populated space right now. And finally, you can wait and see what happens in a short few months. Istio 0.3, they announced, well, they're 0.1, but in the 2 releases on their roadmap, they announced that they're going to include API management capabilities into the mesh. So it would be interesting to see how that happens. We might see with Apogee having joined Google or being built by Google, we might see some interesting innovations there. I'm not sure. If I was building one, I would probably just get out of the proxy or gateway system and just stick to the management capabilities as backend infrastructure. It's the same way that the Prometheus is a backend infrastructure. Gateway management systems could be a backend infrastructure without needing to have, another hub, another layer of tech into our architecture, Be very cognizant of the type of architecture you're going to get into, because until this normalizes, you will be encouraged to insert these gateways along the way that you may not kind of need it. And whether you're picking an API gateway or a service mesh or something in the middle, there are 5 principles that I would use personally to choose a technology and kind of advise the clients I work with. And the first one is this idea of platform thinking or platformness. Does anyone have a good description of what platform is? Or what platform means to you? It's one of those hard ones. We kind of can feel it, know what it is, but it's very hard to describe it. To me, it's an open ecosystem where I can build things on top, or I can, plug in things or capabilities in and out with different technology. Istio is a really good example of an open ecosystem, embracing an open platform. They have built extension kind of points where you can plug in other technology that you have. For instance, you can get the service discovery with Kubernetes, or if you want, and if you have invested in Consul or Zookeeper or other ways of doing service discovery in your infrastructure, you can kind of adapt and plug that in. This is all in theory right now because it's very early, but that's kind of the intention of the architecture. And so any product that you pick, see if it passes that kind of litmus test of the platform. And one of those litmus tests that you can apply is that, can I configure this product with APIs? Does this product embraces open standards, or do I need to commit to a big ball of proprietary technology that can't talk to anything else? A good example of API-driven approach is that, for instance, Kong as an example, to configure or to publish your APIs or to secure them, they built APIs to do that. We've been using that in our build pipelines and kind of automatically configuring the gateway in a very simple model. We've been using it in the edge or kind of the hub model. The other product you might compare it to Nginx is a great, Swiss Army kind of knife, can do so many things, but you have to configure this configuration file that you might hurt yourself playing with the knife. So just think about how the product gets configured. Does it have an API-driven way of extending it and configuring it? Embracing the open source, that's a no-brainer, but I warn you to be careful that not open source is equal, all open source is equal. It has become quite an interesting kind of commercial model for companies, have a product and then make that product open source, and then they provide you, commercial support because you want to call somebody if things fall apart and get an answer. But sometimes those open source products actually have no community around them. So think about the health of the community of that, open source. The commits, how quickly the issues are fixed, who are the contributors, pay attention to that. And embrace diversity. Diversity is good in nature, in society, and in the tech stack. To be honest, if you think about the platformness that we talked about, that you can plug in and out in different tech stacks, that gives you the ability to try different technology. Sometimes in organizations, you don't have a consistent culture. You have subcultures within the organization. You have different skill sets within the organization. So trying to pick one solution that suits everybody sometimes forces us down the path of least common denominator and worst of all worlds. Diversity of tech is not so bad as long as we are adopting open standards for connecting those pieces of technology together. And lastly, the most important one for me would be embracing change. Whatever technology that you would be choosing today, especially in this space, would change very quickly. So think about how you build an architecture that is designed for change. There's a really interesting book that have come out by Rebecca Parsons and Neil Ford from ThoughtWorks called Evolutionary Architecture. Has anybody heard of it or read it already? It's, one person. Oh, no, two people. There's an interesting notion there, the fitness function that you apply to your architecture, taken from genetic algorithms, the objective function that tells you how close you are to the target model or the target system that you want. I would pick change or ability to change as a fitness function for my architecture if I'm in this space, because things are going to change very quickly, and we want to be able to kind of respond to that. So that's all I have to share at this point. I'm sure this topic would change in a few months. So thank you for listening. And please reach out if you want to give any feedback or comments. I'll be happy to hear your questions. Plugin ThoughtWorks, we always hire. We are hiring kind of distributed systems architectures, delivery infrastructure folks who are dealing with the type of problems and challenges that I talked about at all different scales. So if you're interested to join us, come and talk to me or reach out. Thank you.